Hi, it's Mrs. T. Just wanted to talk to you a little bit about Chapter 1, Chemical Foundations. And the very first thing that we're going to talk about in Chapter 1, I have these toolbars that are kind of competing with each other. Hold on, I don't know if I can do this. Is that a big challenge of chemists is to be able to understand the macroscopic world, which means the big world, what we can see, what we can observe, and try to figure out what's happening on the microscopic level based on this. So we want to understand what's happening microscopically, but we can only observe what's happening macroscopically. So in order to start to talk about this, we will talk about atoms versus molecules. And we know that matter is composed of tiny particles called atoms. And an atom is a smallest part of an element that is still that element. And what you'll notice behind me, if I just kind of adjust this a little bit, behind me, I have the periodic table of elements. Okay. And these are all the different types of atoms. This periodic table shows us all of the different types of elements, and that's all of the kinds of atoms that can exist. Whereas molecules, we get molecules, oh, that's not what I meant to do. We get molecules when we get two or more types of atoms joined together. So for example, for a molecule, we are going to have two or more types of atoms joined together. If you have an oxygen atom and a hydrogen atom, and you chemically combine two hydrogen atoms and one oxygen atom, we can get a water molecule. So each sphere represents, so I shouldn't use that color. Each sphere represents an atom. And when they are connected, they connect in a molecule. When we're talking about oxygen and hydrogen molecules, when we use subscripts, that means we have more than one atom in a molecule. And for example, when we're talking about O2, that means two oxygen atoms connected, bonded together. H2 would mean two hydrogen atoms bonded together. And don't forget your diatomics, your Brinkelhoffs: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine will all exist as diatomic molecules. You should check in Google Classroom because you will have to memorize certain prefixes. There is a place in Google Classroom where it tells you that you are going to have a metric prefix quiz. And when you have your metric prefix quiz, the ones that you have to study, you're going to see in that Google Classroom assignment. We know that chemical reactions happen when one substance changes into another substance by rearranging the way that the atoms are attached to each other. For example, if we take two water molecules and we electrify them, we will go from two water molecules to two H2 molecules and one oxygen molecule. The next lesson is going to be about significant figures. And when we're talking about significant figures, there is a series of rules that we use to tell us how uncertain a measurement is. And the more significant figures that a measurement has, the more levels of certainty we have in that measurement. This is based on the device that's used to make the measurement. If we're using a burette, something that I find easy to do, if we're using the burette, remember that whenever you are measuring liquid, you always measure the bottom of the meniscus. But in a burette, the numbers go backwards. So the numbers are actually going from big to small, because in a burette, we're actually measuring the amount of liquid that's being taken out of the burette. We're not measuring the amount of liquid that's inside the burette. So what I tell everybody to do is, if you are looking at it on paper, you literally just turn it to the side, because when you use a ruler, you are taught very young to always read the leading edge, and it's going to go in that same direction, where the part that's furthest to the right in the burette will be the bottom of the meniscus. Now, clearly, we cannot turn a burette filled with liquid on its side. So what we would do is just turn our head to the side so that our right eye is at the bottom, and that will kind of trick our brain into thinking that we're looking at it from the side like that. So we read the bottom of the curve, and the meniscus on this one occurs at about 20.15, because we always estimate one extra place past where past where we have the last measurement that's given. So that with certain digits would be 20.15. Sorry, that was supposed to be underlined, and now I can't get back there, but whatever. The certain digits were the ones at the beginning. So the certain digits would be the 201, and the uncertain digit would be the 5. There's always one estimated number in any measurement. When we're counting significant figures, we know that non-zero integers are always part of the significant figures. So for example, 3, 4, 5, 6 has 4 significant figures. We also know that the leading zeros that precede all non-zero digits are not significant figures. So like 0.048 would only have 2 significant figures. We know that captive zeros that happen in between numbers 1 through 9, would be considered significant digits. And we know that trailing zeros are significant figures if and only if the measurement has a decimal point somewhere. So one of the ways, one more thing is that exact numbers have an infinite number of significant figures. So we actually just don't even consider them in terms of significant figures. Anything that we are going to obtain exactly by an exact conversion or based on counting, we're not going to consider the significant figures there. When we write something in exponential notation, we only use the parts of the significant figures. So if something like 300 with a decimal, oops, I did the wrong thing there again. I'm not getting used to this. Sorry about that. So if we have this decimal point here, that makes these zeros significant. So that means that they would show up in the exponential notation. If we are using exponential notation, we know that every single number that's written before the times 10 power will be considered a significant figure. And because we do not have to write trailing zeros and leading zeros, we're going to have a smaller group of numbers to work with, which makes it easier for us in terms of not making mistakes. When we are doing different mathematical operations, if we're multiplying and dividing, we count the number of significant figures in the pieces that we're multiplying or dividing, and then we round our final answer so that it has the least number of significant figures. When we are adding and subtracting, we actually look for how far out after the decimal our measurements go, and our final answer after we add will go only as far as the one that goes the least number of places. So this one goes 3 places after, this one goes 2 places after. Our corrected rounded answer can only go 2 places after the decimal. One of the ways that some people learn this is that they use what's called the Pacific Atlantic method. And if we're looking, we know that out west, we have the Pacific Ocean, and to the east, we have the Atlantic Ocean. Atlantic stands for decimal absent. Pacific stands for or goes with decimal present. If you have a decimal absent number like 1050, any zeros in the Atlantic Ocean that do not have a number 1 through 9 before them are not significant figures. So that means that the number 1050 has 3 significant figures, and this 0 right here is just a placeholder. We also know that decimal present, if I just do this and put a decimal there, that makes that 0 significant because there are no Pacific zeros here. So this would mean that it has 4 significant figures. However, another type of decimal present number would be like a small decimal present number. And if we had 0.00650, these zeros are in the Pacific Ocean. They are on the Pacific side of the leftmost non-zero digit, so they are not significant. So this number would have 3 significant figures. So that's going to be the end of our first lesson here with a little bit of information about Chapter 1 and significant figures. Please, if you need anything re-explained on here, I highly recommend going back and watching again. If you still need any help at all, please either ask me when you see me in class, or please send me a message via school email or Remind, and I will absolutely get back to you there. I do also have other videos about significant figures posted in Google Classroom, so I do also recommend that you look there. See you soon. Bye-bye.